Alright, so you have 3 lines that all have a slope of 2. So my orange one I think is y equals 2x plus 5. So they all have a slope of 2, obvious, because they all say 2x. This is really to just get across to you the visual reason of the plus c. So if I take the antiderivative of 2x, or sorry, 2dx, it gives me 2x plus c. And we said if there's no limit values, you have to have a plus c. So some of you get a little bit confused about that. If I give you an a and a b number, then you don't have a plus c. Okay, you don't need it. The reason being is when you do this, and you write your plus c, and then you write your a value in there, and you have a plus c, they're going to subtract and cancel anyway, so the plus c is not needed. If you write it, it's not wrong, and if you write it, you still can get the problem right, okay? Just to kind of give you an idea about that weird plus c that you sometimes and sometimes don't use. You only use it if it's an indefinite integral, a and b not given, alright? So this is kind of to show you why there's a plus c, because if I ask you to take the derivative of any of those lines, it's always 2. Which is what that problem asks us for, okay? So that's just a visual representation. So plus c, what does that do to a graph? If you take a function and you just add a number in the end, Nathan, it shifts which way? Try the other one. Vertically, okay? So if I have 2x squared and then I plus 5, it shifts the parabola up, okay? So the plus c just shifts up and down. That's visually what it does. So every answer to an antiderivative, it's going to be a graph, and the similarity is they're all going to look exactly the same except for shifted up and down. So all your parabolas, all your cubic functions, e to the x functions, they'll just be shifted. So this is the start of looking at initial conditions and then actually solving for exact solutions. So here we have the initial condition y equal to 0 equals 5. I just want to make sure you remember that. The inside the parentheses is your input. The equal to value, that's your y value. Some of you don't know that, which scares me. You want to make sure that the input is your x, and then once you put that into the y function, then you get out the y value. Alright? In terms of this problem, I want to do it a very specific way, and for today and from now on, I want you to follow that. I understand that when you look at the problem, you can figure out it's 2x plus c, but there is some process that I want you to follow. First thing I want you to do, I actually want you to multiply the other side by dx. So the problem starts to look like this. And then, now, I want you to integrate both sides. Okay? So, the right side looks more familiar. Most people are very used to that. What's the antiderivative of 2 with respect to x? 2x. Okay. The other side people have a little trouble with because it looks like there's nothing there. Okay? The 2 is multiplied by dx, therefore, what is multiplied by dy? 1. It has to be a 1 in there for you to actually multiply to get that. So, what's the antiderivative of 1 with respect to y? Ooh, with respect to y. Now it's y. That's where the y equals comes from. And then we can put our plus c. And then now I'm going to actually substitute the actual initial value in. Y was 5, x was 0, plus c. C is equal to 5. So the actual solution, if it's a free response question, they ask you for the particular solution. That's usually the way they say it. The particular solution is 2x plus 5. If you leave it at 5 equals c, you'll lose a point. You won't get that last point. Okay? Explain why an initial condition is needed. So what did we end up needing that for? It went from the general solution to the one particular solution. So 2 different ways to say it. Solve for c value gets a particular solution. And I'm saying the word particular because it comes out on the AP. Find the particular solution, y equals f of x. That's what it means. Alright. Give the steps to solving an initial value problem. So what did we actually do? So first, we multiplied by dx on both sides. That's how we got it to the other side. Second thing, we integrate and add plus C. Okay, that was the second step. Third step, substitute initial value xy to solve for C. And then obviously fourth step would be to rewrite the equation. Okay? I'll put that in. I usually don't use that last step, but just keep in mind, if it asks you for the y equals, you have to give it. You can't just leave the plus C. Alright, so general steps. We've done this before. Okay? You saw your initial values more often. They were used to find an ending point. That's kind of an ending value is what I considered it. That was more so what we used it for. We used it in conjunction with FTC2. Now we're saying you can use the initial value to find the particular solution. I think we only solved for C once or twice prior to this section. Okay? Any questions on this before we move on? Because the rest is just a little practice, that's all. Okay? In this section, I think it's actually more important to practice your antiderivatives than the plus C, because once you get your antiderivative, most of you can solve for C perfectly fine. It's making sure your antiderivative is correct, okay? So starting off, this is just to kind of show you the other way to look at the problem is if I gave you two functions, asked you to find their derivatives, if you look and see, the derivatives themselves are the same, but if I took the antiderivative of this, the answers weren't the same. That makes sense. This left side equation had a plus 3, the right side equation has a minus 5, but in the end, their derivatives end up being exactly the same. That's where the plus C comes from. Okay, we're not going to actually do that problem because we'll end up doing it later. So here, these three, it's literally to practice doing antiderivatives. Okay, I'm asking for a general solution. What I want you to make sure you understand is that you don't know any rules right now. The only rules you know are reversing a actual derivative rule such as reversing e to the u, or reversing sine of u, or reversing tangent inverse of u, reversing ln of u. Those you can do. The only other rule that you can do is you can reverse a power rule. That's it. It's all you know how to do right now. So when you look at these three, if you were to take a derivative, they all have a rule, meaning the left one, or letter A, has a quotient, letter B has a chain, double chain, and letter C has a quotient. So I'm giving them to you because you actually can take the antiderivative right now. So there must be a way that you can do each of them. The quotients, let's take a look real quick. Are the quotients, can the quotients be simplified? No, they cannot. Really. There's no way to simplify the quotients. Either of them. There's nothing you can do to them. What do you think you can do? You can, but that's not simplifying it. You haven't done anything to make the problem simpler. Because what did we do to quotients? We simplify them so we get rid of what? The quotient. Can you simplify A or C to get rid of the quotient? No, you cannot. No, you cannot. A 100% no. 100% no. Okay? Alright, so with that said, there's still problems you can do. Alright, so I wrote down just that first part of the process, multiplying by dx, and then the one other thing I did, I pulled all the constants outside of the function so it doesn't confuse me. I don't have extra things. I'll tell you, most people end up getting A wrong, so we'll start with B and we'll come back to it. Alright? So what rule was letter B using? Tangent. Tangent. Alright, so this side gives me the y equals. This gives me 4. You just leave the same. And then here we got tangent of, and what do you do with the inside? Leave it. And then what do I do with the d of the inside? Divide by. So I'm just going to divide it by right here. And then what do I put at the end because I want a general? Plus C. Alright, so I'm going to stop there for a second. Any questions on any of the pieces of undoing that basic chain rule? So then I have a question for you guys. What are the only types of chain rules you can undo? And I want a hand for that. hand up for that. What are the only types of chain rules that you can undo? Because you can't undo them all. They're very specific type. You're limited. What do you think, Nathan? When the inside's a line, that's one way to say it. The other way that I've said it, when the derivative of the inside, thank you Lottie, is a constant. Okay? That's the only kind of chain rule you can undo right now. In 6.2 you'll learn how to undo more of them. Alright, so we got letter B. Letter C I think is usually pretty easy compared to letter A. Alright, so this side we get our y, we get a 2, because we're just going to leave the coefficient in front. And what rule is 1 over 1 plus u squared? Inverse tangent. Alright, so we got that guy. The u was just x, so we get to leave that. So do I divide by anything? No. And then what do I put in the back? Plus c. So we're good. Alright. Anyone figure out A? Anyone have an idea of what they think it might be? Annie, what do you think? Using natural log. So your whole bottom would, I guess, be the u. Okay, let's try it out. Let's see. Let me not use that color because that'll be in the way. All right, so we get y equals 2, you said natural log of negative x plus 1. Don't forget your absolute value. All right, and then did I have to divide by anything? No. Negative 1. So instead of dividing by negative 1, is it okay that I just put it right in front? Okay, because they mean the same thing, right? Okay, and then my plus c. So is that correct? Let's check it, because we don't know. You don't know, you're just saying yes because they said it. Okay, so I'm going to leave my negative 2. So we're taking a derivative right now. ln of u would be 1 over u. And I'm going to leave out the absolute value for a second. Negative x plus 1 multiplied by the derivative of the inside. So what do we get? We get that the negatives cancel. I get a 2 over negative x plus 1 if I disregard the absolute value. Okay? So it is the correct rule. So then we got to talk about that tricky one. So letter A is tricky. Okay? I'm going to show you why it's tricky. Because let's take the one that you have up there. I'm actually going to even simplify it a little bit more. I'm going to change it to x plus 1. But then I'm going to do this. And then I'm going to do this. And I'm going to do this. They all look kind of similar. We agree? Sort of. We already know this came directly from this, so we know for a fact that this is an ln problem, right? Okay, so that's the only one. Out of all of those that look so similar, it's the only one. Okay? This one's a power. Because it'll be a power of negative 2. This one, we just did, inverse tangent. And this one, also power. So ln is really difficult to see because there's so many other things that look like that function but aren't. So I'm going to give you the reason why that first one is ln. So the way that ln works is if your whole entire denominator is to a power of specifically 1 and that the inside has to be linear, as Nathan said, the derivative of the inside has to be 1. Okay, that's how you know right now that it's an ln problem. If those two rules don't work, the whole denominator being a power of 1 and the derivative of the inside being a constant, then it's not ln. So this one would be my way of showing, because a lot of people say, oh, well, that whole thing is a power of 1. Very true. Problem is derivative of the inside is 2x. It's not constant. That's why the third one would not be ln. I think ln is one of the harder ones to recognize. Okay? All right. Any questions on A through C, because D and E are coming up? All right, go ahead and try D and E. E is very specifically tricky. You're not supposed to know how to do E. I'm just figuring logic might kick in and help you figure it out. You don't have to know how to do E. All right, so first step, we're going to move the dx over. That's a to the u. So you only want this part of the rule. That's the only part you want. You don't want the other two parts to be there. So, what do you get? A to the u is still there. That makes sense. Instead of multiplying by ln of a, what are you going to do? Divide by it. And then instead of multiplying by du dx, we're going to divide by it. What is du dx? Since it's only 1, we don't have to divide by it because it doesn't change the problem. So there's the answer. All right. Letter E, you do not need to know how to do. I just put it up there to see how your logic works based off of what you know about derivatives. What function guaranteed will be in the answer? E. E to the. So let's start with integral dy is equal to integral of sine of t e to the cosine of t dt. All right, so I'm going to say this once. I'm going to say it twice. I'm going to repeat it 3 times, okay? At no point in derivatives or integrals are you ever permitted to just break up a product. Ever. Okay? One more time. For derivatives and integrals, you may never just take the derivative or integral of a piece, multiply by the derivative or integral of a piece. Ever. Ever, ever, ever. And third time, you will never, ever, ever just take the derivative of pieces of a product, or I'll even add in pieces of a quotient. There are rules for a reason. It's because you have to use them. So this guy looks like it would be a product rule, okay? Looks like it would be a chain rule. But I'm telling you that you can take the antiderivative of this guy. So you're just going to use a little bit of logic. The e is always interesting because what's the derivative of e to the u? E to the u. So that has to stay. Does that make sense? That has to be there. So I do know that e to the cosine of t better be part of my answer. Okay? Anthony said you also need to divide by the derivative of the inside, don't you? Nathan, what's the only time you're allowed to divide by the derivative of the inside? When the derivative of the inside is a constant. Is the derivative of our inside, which is cosine of t, a constant? No, so you will not do that. Okay? You're going to say in a second, wait, but you could. No, you can't, okay? And now we're going to look at it and say, if I took this guy's derivative, would I have what I started with? Sine of t e to the cosine of t. I wouldn't? What am I missing? If I took, and if I'm saying if I took, why don't you just take the derivative and see what happens? Take the derivative of e to the cosine of t. You get, what do you get? Negative sine of t e to the cosine of t. So what's actually hiding there? That's the dn that's just hiding there. That's where that product comes from. So this is not the answer. What do I have to add in? A negative and then a plus c. No, you don't need to know how to do that. I thought it'd be interesting to see that that product is a direct result of a chain rule. Okay? A lot of your products actually are a direct result of your chain rule. Okay? So, Anthony, no, you cannot just divide by the derivative of the inside unless it's a constant. Okay? Alrighty. So that was good. Let's look at the last thing here, and then I think I have one more page. So when you take the integral of f of x dx, it is equal to the antiderivative plus c, and then c, if we have an initial value, we'll be able to find a physical number. So I didn't do many examples of that because we put in the plus c. I'll just give you a point. You should be able to solve for the final c value. All right, we good up to there? Yes, no, maybe so? Yes, possibly? Okay. So, this guy came from the very beginning where I was showing you the two functions. The derivative of y is equal to 2x and y equals 4 when x equals 1. Find the equation. So, this is obviously, you have an initial value. I only show this because I do want you to rewrite y prime as dy dx. I do want you to rewrite it. Getting to good form, multiply by the dx, and then integrate. So what do we get? Y equals 2x's antiderivative is? No. X squared, and then what do I need in the end? Plus c, and then the point we're going to use is 1 comma 4. 4 is equal to 1 squared plus c, so c is equal to 3. So my final answer is y equals x squared plus 3. This is kind of how I show that I'm going to put in an initial value. I just write the point next to my c so I know. Please make sure you put the right one in the right place. The x goes in where the x's are, the y goes in where the y's are. Please don't mess that up. Okay, you end up with the wrong equation in the end then. Okay. I think there's 2 more examples that I want you to try. So find the exact solution for y. So you guys should have something that looks like this. And I'm going to pull my 5 out front so that it's not in my way. I don't get confused by it. Alright. And let's see. Ellen, what'd you get for your cosine of 2x's antiderivative? Good. Beautiful. Beautiful. Perfect. Alright. Make sure you don't get confused with your negative because that starts to get very confusing. And then we're going to substitute in the point pi over 4 comma 3. So 3 equals 5/2 sine. And if I put in pi over 4, I end up actually getting pi over 2. So I'm going to do that in one step. Sine of pi over 2. That's up here. Y value is 1. So I get 3 equals 5/2 plus c. So c is, hopefully you all got 1/2. That's what I got. And then don't forget to rewrite your answer. Alright, any questions on that guy? Alright, let's look at the last one. There is one little thing I want to mention about the last one. So you see how there's a big old minus there? When you move the dx to the other side, it really does multiply by all of it. Which there is a rule that says if there's a minus or a plus, you can actually separate integration if there's a minus and plus. We remember me repeating 3 times that it can't work with product and quotient, but adding subtraction, yes, you can break it up if you'd like. I don't. I usually just do piece by piece. So this side is y equals 2e to the x. Lottie, what do you get for your antiderivative for 2e to the x? So what should I do with the 2? Bring it down. What's the antiderivative of e to the x? E to the x. Do it piece by piece. Alright, we got that guy. Alright. Ramsey, what do you say about negative cosine of x? What is it saying? You got it. Negative sine of x. Alright, Davis Oriano, what am I missing there? My plus c. I'm going to substitute in 0, 3. I tried to write it all different ways because they keep giving it all different ways. Alright, so we get 3 on this side. I get 2e to the 0 minus sine of 0 plus c. So, now that I have that much, Timon, what's e to the 0? Anything to the 0 power is 1. Alright, so I can cross that out because 2 times 1 is just 2. Annie, sine of 0 is 0 because that would be the right side of the unit circle. Y value is 0, so I don't need to subtract 0, so I'll take that out. So what do we actually get? 3 is equal to 2 plus c, so c is 1. Y equals, don't forget to rewrite, plus 1. I think the fact that in your books it's kind of hard to be able to tell. I think they're pretty good about it, but maybe I'm not as good about it. The dx is always multiplied by the whole integrand. Always. Okay? And that's really important because of these kinds of problems, and when we get to section 6.4, it's very important. If you remember at the very beginning, on Wednesday, you have a quiz on what? Integrals and derivatives. No secrets. I literally am just going to give you a bunch of derivatives, a bunch of integrals. They're going to be mixed around, and you're just going to have to do a bunch of general solutions. You won't be solving even for plus c. Okay? That's just to double check that you are still keeping up with all your rules. All of them, even the ugly derivative of the sine inverse or secant inverse of x. Okay? And otherwise, homework tonight. Oh, I'm going to do that tomorrow because I didn't do it with the other class either. I'm going to hold off with that. All right? So homework tonight, number 1. I didn't give you the syllabus, so it was on the front. All right? Numbers 1 through 19 odd, 20 to 24. And then if you did not complete your chapter 5 part 2 test corrections, you have about 5 minutes. If you have parts that you know you can't answer or you're confused about, you can ask people in here. I'm going to read off the amount of points each one was worth, if I can try and remember. Let's see. Let's move over. I'm going to do the ones I remember a little bit better. I remember this was 2, 2, so that's 4, so 5 points, that's 3 and 2. Number 1 was 2 and 2, that's 4 points, so I think this was 3 and 2. Number 2 was 2, 1, 3, 3. I believe those are the point breakdowns for each question. A, B, C, D. That way you know, that way you know if you got a part wrong, which part you lost the points in.